Hello, this video is regarding Internet of Things project. This project is regarding creating a library to compute over continuous stream of data generated by sensor devices like Arduino. As we know that sensor devices are getting common and cheaper, many of the industries are using sensors. For example, biomedical industry, chemical industry to detect hazards, aerospace is using sensors. There are other industries like energy department to continuously monitor the energy consumption and to save the energy. There are lots of applications on analyzing sensor data and in various industries. So I have created a library to help these applications analyze the sensor data. So what are the main programs that can help the applications to analyze the sensor data? So first of all, let's see the search on Google Scholar about moving average. So if you see moving average search on Google Scholars, you can see there are 263,000 publications. Those are patents and publications on Google Scholar. And the next you can see moving average with sensor. So sensor data, moving average publications are about 27,400. And another common application is spike detection. So if you search spike detection with sensor, you can see all these links and you can see 27,800 publications on the same. So spike detection and moving average is very important for sensor analysis of sensor data. So I have created moving average and spike detection programs as a library to be useful for all these applications to use, and it is really fast and horizontally scalable to work on multiple machines on a cluster. So here I want to demonstrate this Arduino circuit. I have created a circuit which detects the light intensity. Here is the photoresistor, if you can see, and let's see on a serial port that it is generating this sequence of light intensity events. So it is continuously generating light intensity events at the rate of 9,600 baud, so 9,600 symbols per second. And this is the intensity symbol 3,900, around that figure. So if I move my palm over the photoresistor, now you can see those intensity values are changing. So it's 4,200. Now I keep it here. Now 5,000 something. So those are changing as I move my palm over the circuit. So now we are so this is generating 10,000 readings per second, and my program will actually process all those, compute moving average over this, and with a configurable window. And at the same time I have created a spike detection program which will continuously check the moving average and the current event, and you can set the threshold to detect the spike, and it will sort of detect the spike with that threshold. So let's run my program. So it will take a couple of seconds to start because the main reason is it's a distributed system. So I'm currently running on only one node, and I will show it on multiple nodes later. So the first number here is the moving average. Second number here is the events. So if you can see now here, I will just move my hand over this device, and then we can see the spike detected. So if we do this, then you will see here the spike detected. So this goes. If I move my hand, those things, and it's very fast. If you see this, it's coming and going, coming and going, coming and going. If I move my palm here, so let's just stop quickly and see the spike detected things. Yeah. So now we can analyze where the spikes are detected and why. Okay, so spike detected. So as you can see, the moving average here is 4040.6 and this is 4989, and the readings were like 3989 earlier. So there is a lot of amount of change in the event, and I have configured the spike detection threshold to be 10%. So this is 0.1 float, which is 10%. So if there is a difference between moving average and the current value of the spike is more than 10%, then it will show the spike detected. So you can see is same, like the events were on in the range, and when I move my hand, move my palm there, it showed this, like it detected that, and it quickly came up like the spike detected. So sort of these spikes I measured, these spikes are actually getting detected about in 1 millisecond. So that's how the like the setup is. It's very fast. So this is only with one machine. I have created a cluster of 3 machines, and I have benchmarked with this particular application that it processes 100,000 messages per second. And I will go in technical details later, but it can process 100,000 messages per second, and it can detect the spike within 100 microseconds. So which implies that if you see here in the logs, it also detects the device ID. So I have created a hash map which says like this device detected a spike. So as I had only one circuit to connect to the serial port and not many other devices streaming data, so sort of right now I can show only with one device. So according to the benchmarks of number of messages it can process, it can easily listen up to 1,000 devices or more than that, just creating a cluster of 3 machines. And we can use this library for various applications, for various industries, as we know that moving average and spike detection is very, very common to analyze the sensor data. Another thing is there is another open source platform which is very famous, Hadoop, that we cannot use. The main reason is Hadoop response time is very slow. It can go into seconds, almost up to a minute, and here the response time is in milliseconds. Probably we can make it down to microseconds. It's really extremely fast. So it's very useful, and I hope this will be widely useful. Thank you very much.